We're going to do a quick overview of the solar system, and you're going to get more detail in the other videos. The solar system is defined as everything that orbits around the sun and the sun as well, plus the things that orbit around the things that orbit around the sun, like moons. So if we do an inventory, we have one star, that's the sun. We have 8 planets, 4 terrestrial, 4 jovian. We have a handful of dwarf planets, the most famous being Pluto. We have hundreds of moons, thousands of asteroids, thousands of Kuiper belt objects, and millions or perhaps billions of comets. And each object not only revolves around the sun, but it also rotates on its own axis. Now, the sun is different from the other objects in the solar system, not only in size, which you can see here, but also because it's the only star. More about stars next week. Essentially, a star is a big ball of hydrogen and helium gas that creates its own energy by fusing, by nuclear reactions of hydrogen into helium. Again, more on that next week. Now, our sun is pretty average as stars go. It's about 4.5 billion years old, and it's going to start to die in about another 5 to 6 billion years. Again, more on that next week. Of course, you know you should never look directly at the sun, but with a special filter on a telescope or something sort of like those glasses that you might have worn during the total solar eclipse a few years ago, you can actually see what we call the visible surface of the sun, in scary air quotes because it's not solid, it's a ball of gas. We call this the photosphere, and these dark appearing areas are sunspots. More about them in another video. But when we block out the light from the photosphere during a total solar eclipse, we can see that there are 2 other outer layers on the sun. We have this beautiful ghostly white layer called the corona, and then we have this sort of pinkish layer sandwiched in between the corona and the chromosphere, and between the corona and the photosphere, and this is called the chromosphere, chromo coming from the word for color. Now, when people ask who discovered the planets, well, most of the planets you can see them without a telescope, so they've been known since ancient times, which is why they're named after ancient Roman gods and goddesses. But Uranus was discovered by accident. Neptune was predicted and then discovered. More on that in another really short video. And planets are different from stars because they don't create their own energy. They don't shine. And how did they know that these things were planets? Well, they didn't know what they were. What they did know is that relative to the background stars, these particular wandering stars, that's what planet means, wanderers, they appeared to move relative to the background stars independently. They didn't stay in just one constellation, for example. And that's how the ancient people knew they were special. Now, the planets orbit the sun in nearly circular orbits. Again, technically they're ellipses, but they're not that squished ellipses. And all the planets orbit the sun in the same direction. If you're looking down on the solar system, it's counterclockwise. And what I want you to notice here is that the spacing of the orbits of the planets is not even. The 4 inner planets, Mercury, Venus, Earth, and Mars, are all relatively close to the sun, relatively speaking, with millions of miles, of course. But look at the large gap between the orbit of Mars and the orbit of Jupiter, then the orbit of Jupiter and the orbit of Saturn, and then Saturn and Uranus, and then Uranus and Neptune. And here's your first clue that Pluto just ain't quite right. Notice that the orbit of Pluto actually overlaps the orbit of Neptune. Now, the interesting thing is that there's a natural dividing line between the inner terrestrial planets and the outer Jovian planets. And that's the existence of what we call the asteroid belt between the orbits of Mars and Jupiter. The terrestrial planets are called Earth-like. They are made of rock and metal, so they have a high density. There are some differences. The Earth is the only planet with known active plate tectonics. More on that in their own video. But Venus and Mars have volcanoes that we think are extinct, so they had geologic activity at one time. Mercury is heavily cratered. It's very similar to our moon, but it's a little bigger than our moon. And Venus is actually the hottest planet. It has a very dense carbon dioxide atmosphere that smothers it by trapping heat. So for people who have a problem with global warming, let's just look at Venus for a really extreme example in that. Mars also has a mostly carbon dioxide atmosphere, but it's a very thin atmosphere that doesn't really act as a blanket and doesn't really trap any heat. But we know that Mars was warmer in the past because there are signs of that there was once liquid water. There's dried up riverbeds and dried up lake beds. So Mars was once warmer and wetter, which of course is very interesting for people looking for signs of life elsewhere. Now, we explore the terrestrial planets using all sorts of spacecraft. There are flybys, there are some that orbit planets, and we actually have landers. Now, the landers that went to Venus didn't live very long, not just because it's hot enough to melt lead there, but also the clouds are made out of sulfuric acid, which isn't exactly good for spacecraft. And the surface pressure on Venus is about 90 times the atmospheric pressure on Earth. So they have to build these things like tanks or submarines, even though they're very small. And so of course, unmanned probes that we've landed on Venus didn't send back signals for more than a few days. Now, Mars is a bit more hospitable. It's been in the news because we have the latest rover there with the cool little helicopter. Because stuff is changing all the time, that's why I'm going to be putting in links to websites from NASA, which are very up to date, more up to date than any video I can make. Our moon is interesting because it's the only natural satellite to our Earth. It's the only object that humans have walked on personally besides the Earth. Really has no atmosphere, has a tiny bit of water ice frozen on its surface. If you look at our moon, it's very obvious that there are different kinds of features. We have craters, obviously, which is where pieces of space junk impacted the moon. These rays are literally splash marks where the material sort of splashed up and fell back down. And so we have part of the moon's surface which is heavily cratered, and that's what we call the highlands. And then we have these depressions, these darker, lower areas, and we don't call these lowlands. We call them maria. Maria is Latin for seas because at one point people thought they looked like water. They actually have nothing to do with water. They are actually dried lava. They are sort of scabs left over from very large impacts that melted a lot of rock on the moon. Now, there's really no active geology on the moon except for an occasional small crater created by something impacting the moon. And it is very large compared to the size of the Earth. It's a quarter the size of the Earth, which to have a moon a quarter the size of its planet, that's really important because remember when we talk about gravity, the relative masses and sizes of things are going to affect gravity, right? So the moon and the Earth have a very intense gravitational pull on each other, and that's what actually causes tides. Now, the formation of the moon is something that's bothered astronomers for a very long time. You know, how did the Earth get a moon that's so big? We think that what happened was that the Earth was minding its own business when it was very young and molten and semi-squishy, and another object actually smacked into the Earth, sort of a glancing blow, if you will, and some material was ripped off of the Earth, and that combined with some of the debris from the object that hit the Earth, and that later pulled itself together by gravity and formed our moon. The outer planets, the Jovian or Jupiter-like planets, Jupiter, Saturn, Uranus, and Neptune, are sometimes called gas giants because they're all much larger than the Earth. And they're really soft and squishy. They're mostly made out of gas, hydrogen, and helium. They have a low density. They have many, 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 many moons, but most of the moons are very small. And although you usually say, oh, Saturn's the ringed planet, all four of these planets actually have rings. Saturn's are just the best, brightest, biggest, the most awesomest. But all of them have rings. And the rings are made out of tiny, tiny individual particles of ice and rock that orbit around their planet. If you look at these photographs, you can see that there are features. There are these stripy things, and then there are these spotty things. So these are sort of weather systems in the atmospheres of the outer planets. Now, we've sent flybys to the outer planets, we have orbiters around the outer planets, and we found something really cool. That because these planets are very big, they can have very big moons. And some of these moons are not only larger than our moon, but some of these moons are actually as large as the planet Mercury or larger, which means that some of them have enough gravity to actually hold atmospheres. For example, Titan, the largest moon of Saturn, has an atmosphere denser than the Earth, and many of these outer moons actually have oceans of water under a frozen icy crust, which again is really great for people interested in looking for signs of life. So here we have again the relative sizes of the 8 planets, and here's little Pluto. Pluto is an example of what we call a dwarf planet. I have a short several-minute video explaining sort of the politics of how Pluto got demoted. Essentially, we didn't have a really good definition of planets up until 2006. One can debate whether or not the definition we have now is any good. But it turns out that we actually defined a planet as an object that has enough gravity to pull itself into a round shape and orbits the sun. But a planet also has to clear its orbit of other objects, and Pluto fails this part of the definition because its orbit overlaps Neptune, and therefore it was reclassified as a dwarf planet. Now there are other dwarf planets. The largest of the one of the largest of these is the largest asteroid known as Ceres in the asteroid belt. There are various types of what we call space junk. These are things that are left over from the formation of the solar system. And they're sort of classified by what they're made out of and where they're found. So asteroids are made out of rock and metal. Most, but not all, are found in the asteroid belt between the orbits of Mars and Jupiter. And unlike what you see in the movies, they're very far apart. It's really easy to steer a spaceship through the asteroid belt. And some asteroids have the possibility of crossing the Earth's orbit, which means we have to keep an eye on them. Comets are sort of dirty snowballs. They're made out of ice, some drinkable, eatable ice, some poisonous ice, and dust, and they're relatively small, a few miles wide. And when they're in the outer solar system, they stay nice and frozen and boring, but when they get near the sun, they sort of wake up. The ice turns to gas, we say it sublimates, and the influence of the sun pushes these loose particles back, forming like a windsock, like a tail. And because comets fall apart when they get near the sun, the orbit of a comet is strewn with little bits of junk that we call meteoroids. And when the Earth passes through the orbit of a comet, some of these little bits can actually hit the Earth. Well, they burn up in the Earth's atmosphere, making a streak of light called a meteor, or a shooting star or falling star. It has nothing to do with stars. Most of it burns up, but if a piece survives and hits the ground, we call it a meteorite. There's a little video where I show you some of my meteorite collection. And if before you feel bad for Pluto, Pluto is actually a member of what we call the Kuiper belt. Comets are found in 2 main regions of the solar system. Really, really far out, the farthest edge of our solar system in what we call the Oort cloud. Those are comets that have periods of like millions of years. And then there's another realm of comets a little closer in, right around the orbit of Pluto. And these are larger objects. These have shorter orbits. They orbit the sun every few hundred years, like Pluto. And this is where there's also a bunch of dwarf planets. So this other region of icy bodies, the Kuiper belt, that's where Pluto's family is. So it's like the ugly duckling. Pluto's only an ugly duckling if you think he's a duck. He's actually a Kuiper belt swan.